This part of the question that's in brackets here, it's not necessary to solve the question, but it might help some people visualize what's going on. So if we have a magnetic field into the page, I'll just draw a little bit here, maybe a 4x4. And then we have an electron moving to the right. So we'll have an electron. So that's a negative charge, actually. The velocity's to the right. Then the magnetic field is going to make that electron curve. It's going to curve into a circle, actually. And if I use my right hand rule, I'll have my index finger pointing left, because it's an electron, it's a negative charge. My middle finger pointing into the page, so my thumb points down. Therefore, the initial acceleration of this particle is going to be down. So it'll start to curve into this kind of a circle. So it's going to end up going in uniform circular motion, always experiencing a magnetic force towards the center of that circle due to right hand rule number 3. Okay, so that's kind of what's going on. I didn't have to write those words in the brackets there. You could still answer the question. This is just a way to visualize it. It makes a circle, basically. Okay, so now let's get started on solving this here. First of all, we may have to look up some information about electrons. You can go to the useful values page, and for an electron, you'll find that the charge they list is negative 1.6 times 10 to the negative 19 coulombs. And you'll find the mass that they give of this electron is 9.11 times 10 to the negative 31 kilograms. All right, now some other pieces of info they give you. They tell you how fast the electron's going, that's the speed, and they tell you how strong the magnetic field is. So I'll list those as well. So we have the V value being 1.6 times 10 to the 7. And we have the B value being 8.0 times 10 to the negative 4 Teslas. All right, so in terms of Senneckerman equation, we're supposed to determine the radius of this circular motion. So we're going to need a circular motion formula in here. So that would be that the centripetal force will equal to the mass times the centripetal acceleration. That's Newton's second law. And the centripetal force is going to be caused by the magnetic force. That's the force that's pointing towards the center of the circle on this particle. So the magnetic force has a formula. It's QVB. So I use the scalar version of that formula where the assumption is that V and B are perpendicular to each other, which it says in the question. Okay, if V and B are perpendicular to each other, we don't have to bother with the whole sine theta part of the formula. And the centripetal acceleration, we go back to a uniform unit 1 formula. It's V squared over R for the centripetal acceleration. So what I'm going to do is solve for R. Have a little bit of cancellation going on with the V's. Got one V cancels here, and one V cancels there. And rearranging for R will leave me with mv over qb. So what you'll find is a lot of these problems today, this is the formula that's going to be used, and they just ask you to rearrange for one thing or another. In this case, they're asking us to rearrange for R. Okay, so I'll fill in the values. Q, I know it's a negative charge, but Q in the formula is the magnitude of the charge. So I'll just put positive 1.6 times 10 to the negative 19. In the magnetic field, okay, so let me calculate that out. Okay, so to 2 sig figs, I have 1.1 times, let's see, the power of 10 is going to be, I'm going to use my exponent laws here. So I got negative 31 plus 7, that makes negative 24. Take away negative 4 makes negative 20. Take away negative 19 makes negative 1. So just negative 1. So basically 0.11 meters or 11 centimeters.